Welcome to a special edition of Math in the House. This is a cool edition. We're in Calculus, Chapter 3, Section 5. The chain rule. The chain rule, a very important concept in calculus. I'm your host, Dr. D. And here we go. Chain. Okay, that's it. Let's get started here. The chain rule. This is a seriously important concept, and you really want to make sure you get it. So, we've got a function here that's a composite of two or maybe more other functions. So, capital F of x equals f of g of x. Now, the derivative of this capital F function is going to be the derivative of f of g of x times g prime of x. Okay, so we're going to take the derivative of the outer shell, and then you take the derivative of the inside and you multiply. Now, another way of thinking of this is if y equals fu. Hey, watch your mouth. Okay, so y is f of u, and u is g of x. So notice y equals f of g of x. So if I want the derivative of y with respect to x, then I need the derivative of y with respect to u. See, notice y equals f of u, so the derivative of y with respect to u, dy du. So that's really f prime of u. Now what's u? It's g of x. So that's really f prime of g of x. Now, then I need to multiply by du dx, which is really g prime of x. So there we have the f prime of g of x times g prime of x. Now I realize this doesn't make that much sense right now, and once again I'm going to say the proof is in the book, but what I want you to do is understand the process of evaluating the derivative of a composite function using the chain rule. So, let's check out some examples. That's going to be the easiest way to understand this. All right, so we start with the function capital F of x equals the square root of x squared plus 1. Now this really is a composite function because small f of x is going to equal x to the 1/2, or the square root of x. See, all I did here was say, let's make our square root the 1/2 power. So small f of x is my parenthesis to the 1/2 power. Now what's inside that parenthesis is the g of x function, which is x squared plus 1. So that means f of g of x is going to be plug the g function into the x here, and I get x squared plus 1 to the 1/2. Now, what is f prime of x? It's 1/2 x to the negative 1/2. Now, what is the g prime of x? The derivative of the inside is 2x plus 0, so just 2x. Now, the f prime of g of x is going to be the outer shell, and then the g prime of x is the derivative of the inside. So let's do this on our function then. So f prime of x is going to equal 1/2 times x squared plus 1 to the negative 1/2. So all we did was we treated the parentheses as if it's just x. But now what we have to do is we have to go back in and take the derivative of the inside, which is my g prime of x. So what I have up there right now is just f prime of g of x. And now I multiply by g prime of x, which is the derivative of the inside, which is 2x. And that is the chain rule. Okay, so now all we have to do is simplify this stuff now. So we've got 1/2 times 2x, which is just x, and then x squared plus 1 to the negative 1/2 becomes the square root of x squared plus 1. That's it. Game over. F prime of x equals x over square root of the quantity, x squared plus 1. There's your chain rule. All right, so let's try some more examples. What about y equals sine of the quantity x squared? Well, really what we have then is the outside function is sine of x, sine of something. So that means the derivative is going to be the derivative of sine, which is cosine. But now we have to take the derivative of the inside, which is 2x. And we'll put the 2x in parentheses because it's only cosine of x squared. Then we multiply by 2x. So we say our final answer is 2x cosine of x squared. There's our derivative. Notice the chain rule is simply taking the derivative of the inside. Okay. Here we are. Instead of y equals sine of x squared, we have y equals sine squared x. Now, this we could rewrite y equals sine of x quantity squared. That's what sine squared x means. Okay, now let's take the derivative. So dy dx is going to be the outer shell, the derivative of the outer shell. So we basically treat this as if it's x squared. So what do? We go 2 times sine x to the first. So all I did was take the power rule, I brought my 2 down in front, and I dropped my exponent by 1. Now what I have to do is multiply by the derivative of the inside, which is cosine x. So there is my chain rule again. Okay, so our final answer then is going to be 2 sine x cosine x. So that's kind of interesting when you think about it, because if you remember this, 2 sine cosine is sine 2x. So the derivative of sine squared x is sine 2x. So that's it. Game over. All right. Cruising onward. What about y equals x cubed minus 1 to the 100th power? Well, with the chain rule, it's a piece of cake. All we do is we go dy dx equals 100 times x cubed minus 1 to the 99th. So basically I just treated the parentheses as if it was an x. And I just bring the exponent down and drop it by 1. Now, though, I need to take the derivative of the inside, which is 3x squared. So my final answer is going to be 100 times 3x squared, which is 300x squared, times x cubed minus 1 to the 99th. That's it, game over. All right, now, what about f of x equals 1 over the cube root of all that stuff? Well, let's rewrite this. F of x equals x squared plus x plus 1 to the negative 1/3 power. Remember, cube root is 1/3 power, since on the bottom it's negative 1/3 power. All right, now we're going to take the derivative of this thing. So we go f prime of x equals, well, I'm going to treat the whole parentheses as if it's just an x. So I go negative 1/3 times parenthesis x squared plus x plus 1 to the, now drop that by 1. Well, negative 1/3 minus 1 is negative 4/3. Now we need to take the derivative of the inside because we need the chain rule. Okay, so we go, the derivative of the inside is 2x plus 1 plus 0. Okay, so the final answer then is going to end up being negative 2x plus 1 over 3 times the x squared plus x plus 1 to the negative 4/3. So we could clean that up a little bit. We could say, let's just, okay, we've got 2x plus 1. Well, let's make it negative 2x plus 1 over 3. Now, this is the cube root of all this junk to the 4th power. So why don't we just go cube root of all this junk to the 4th power. And that's, you know, we could rationalize and get the radical out of the denominator, although it would end up being more, it'd be messier to do that. So we just stop right there. Okay. All right, now, we've got a function whose composite is a quotient. So we're going to have the chain rule combined with the quotient rule. Oh, yeah! Okay, that's enough of that. All right, so check that out. We go f prime of x equals. Now, just consider everything in parentheses like it's x. So we're taking the derivative of x to the 9th. Well, what is that? That's 9x to the 8th. Oops. Oops. Okay, there's 9x to the 8th. Now, we need to take the derivative of the inside because it's the chain rule. It was a little loud there. Okay, so we multiply by the derivative of the inside, which is going to be low d high minus high d low, square the bottom. That's obnoxious. And away we go. Okay, notice. You take the 9, put it down in front, drop the exponent by 1, and leave everything as is. So that's the outer shell. Now we take the derivative of the inside, which is low d high minus high d low, square the bottom, away we go. And once again, we can clean this up. We can make this, okay, 9, yeah, let's just do this. X minus 2 over 2x plus 1 to the 8th. Now what we have here is 2x plus 1 minus 2x. Yeah, let's just do this. So it's 2x plus 1 times 1 minus 2 times this. So it's going to be minus a 2x and plus 4. Because we've got a minus 2 times 2. All over 2x plus 1 squared. So now we have 2x minus 2x is 0, 1 plus 4 is 5. So we've just got a 5 up on top and a 9 up on top. So 5 times 9 is 45 over 2x plus 1 20 squared times, yeah. You know what, so I don't confuse people, let's do this like this. It's going to be x minus 2 over 2x to the 8th times 45 over 2x plus 1 squared, which then is going to equal, if I just multiply this out, I've got my 2x plus 1 to the 10th on the bottom. And on top, I've got 45 x minus 2 to the 8th. Now, of course, we want to distribute these out. No, just kidding. No! No, we want to leave them in factored form, so there's your final answer. Let's see what the book came out with. Yeah, they're right, too. Okay, that's handy. All right, so let's cruise onward. Now we're going to combine the chain rule with the product rule. So check out, yeah, we're out of board. Okay. So 2x plus 1 to the 5th times x cubed minus x plus 1 to the 4th. All right. So notice we've got a product and we've got a composite. Well, two composites here. So first thing we do is go first times derivative of the second. So first, oops, kind of shortcut that, y equals that. So dy dx equals first times derivative of the second. What's the derivative of the second? It's 4 times x cubed minus x plus 1 to the 3rd. Notice all I did was treat this whole parenthesis like an x value. So I go 4x cubed. Now I have to multiply by the derivative of the inside because we're using the chain rule. Okay, so we've got times 3x squared minus 1. Okay, so there's our first times derivative of the second, plus second times the derivative of the first. Well, the derivative of the first is going to be 5 times 2x plus 1 to the fourth. See, I just brought the 5 down, dropped the exponent by 1. Now I've got the chain rule. So I have to multiply by what's in the derivative of the inside, which is 2. That's it, game over. The calculus is over. Now begins the algebra. So basically all we do is simplify this big mess. So I've got, 4 times 2x plus 1 to the fifth times x cubed minus x plus 1 cubed times 3x squared plus 1, or 3x squared minus 1, plus 10 times x cubed minus x plus 1 to the fourth times 2x plus 1 to the fourth. Now, what I could do is factor out the greatest common factor of these two, which is going to be 2 times 2x plus 1 to the fourth, because between my 2x plus 1 to the fifth, 2x plus 1 to the fourth, the biggest one is 2x plus 1 to the fourth. Now, between the cube and the fourth power, the biggest one of those is the cube. Okay, now I multiply by what's left. So I have a 2 left here. 2 times 2 is 4. And 2x plus 1, I need one more of those 2x plus 1s. So I go 2x plus 1. And then notice I have the cube here. Now I have to multiply by 3x squared minus 1. Now, over here, I need a 5. Because 2 times 5, 2 times 5 is 10. Now I need one of these dudes here because I have to the fourth power, and here it's only to the third. So I have x cubed minus x plus 1 to the first. And then notice the 2x plus 1 to the fourth is already accounted for. So that's it. Good thing that's all I needed because I'm out of board space. Okay, now what we could do is distribute this, distribute that, combine like terms, and then we have a third factor. And what does that turn out to be? That turns out to be 2 times 2x plus 1 to the fourth times x cubed minus x plus 1 cubed times, when you distribute all that and combine like terms, you end up with the 17x cubed plus 6x squared minus 9x plus 3. That's it. Game over. So don't forget what you learned in the past. We've learned the chain rule now. You want to remember that. But you don't want to forget your product rule. First times derivative of the second, chain rule in there, plus second times derivative of the first, chain rule in there. Okay. Just a couple more examples here. E to the sine x. Okay. If y equals e to the sine x, what's dy dx? Well, e to the x, the derivative of e to the x is just e to the x. So I treat that sine x as just a plain x, and I just go e to the sine x. Now I take the derivative of the inside of that function, which is sine x. What's the derivative of sine x? Cosine x. So the final derivative is going to be cosine x e to the sine x. Okay, notice chain rule means the inside of the function. See, if we go, the small f of x is e to the x, and the g of x is sine x. So now we've got capital F of x being f of g of x, which equals f of x e to the x. What do we plug in for x? The g function. So there's my e to the sine x. So I take the derivative of e to the x, which is just e to the x, although the x is really a sine x. Then I go, okay, now I want the derivative of the inside, which derivative of sine is cosine. Okay, now we've got a new concept here then, that the derivative of a to the x is a to the x natural log a. Yeah, notice, let's just do this. If I have a to the natural log of a, or I'm sorry, e to the natural log of a. Okay. Yeah, a equals e to the natural log of a. Now we know this is true because the exponential and the logarithm are inverses of each other. So e to the natural log of anything equals that thing. Okay, so a equals e to the natural log of a. Now, if I want a to the x, well, that equals e to the natural log a to the x power. Okay, so what do I do when I have a power to a power? I multiply the exponents. So that becomes e to the x natural log a. Okay, so now e to the x times natural log a means that the derivative, we're going to start with y equals a to the x. So that means y equals e to the x natural log a. All right, so now if I want the derivative of a to the x, notice I have the derivative of e to the x, which is going to be e to the x natural log a times the derivative of the inside. Well, that's got to be natural log a. Okay, so now what do I have? Well, this e to the x natural log a really is e to the natural log a to the x. Well, e to the natural log a is just a to the x. Oops, natural log of a. let's say natural log. All right, so what I've just done is I've shown that if y equals a to the x, then dy dx equals a to the x natural log a. So the derivative of a to the x equals a to the x natural log a. The derivative of e to the x equals e to the x natural log e. Now notice natural log e just equals 1. So basically the derivative of e to the x is e to the x. The derivative of a to the x is a to the x natural log a. Now what's an example of that? Well, if I know that y equals 5 to the x, then I know dy dx equals 5 to the x natural log 5. Don't forget natural log 5. That's basically your chain rule. Okay, so that's it. Now cruising onward, we've got just a couple more examples where we actually have more links in the chain than just one. So let's do this thing. I kind of like example 9 to go first. So let's go y equals e to the secant 3 theta. And just to keep it the same, y equals e to the secant 3x. All right, so dy dx equals. Now we treat this as if it was just e to the x. So what's the derivative of e to the x? It's e to the x. But now we have to take the derivative of the inside. Well, what's the derivative of secant 3x? Well, I know the derivative of secant x is secant x tangent x. So the derivative of secant 3x is secant 3x tangent 3x. Now, notice I just treated the 3x as if it was just a plain x. Well, it's not a plain x, it's a function of x, 3x. So now I have to take the derivative of the inside of that, which is 3. So the derivative is going to equal, yeah, we can put it in any order we want, so let's just go 3e to the secant 3x times secant 3x tangent 3x. So notice we don't just have one chain rule here. We have the first e to the x gives us the derivative of that is e to the x. Then you take the derivative of secant x, and that's secant x tangent x. Then you have to take the derivative of the 3x. So we have a chain in a chain in a chain. And that's why we have the song. Chain, chain, chain. Chain of fools. Okay. So, there we are. Okay. So, lastly, we have another chain in a chain in a chain. So we've got f of x equals sine of cosine of tangent x. Notice, this is really, well, let's just call this, we'll call this f of x really equals the sine function, which we'll call the g function, of the cosine function, which we'll call the h function, of the tangent function, which we'll call the I function. So notice we have a g of h of I of x. It's a function within, well, it's a function within a function within a function. It's tangent x, but then we're taking the cosine of tangent x, then we're taking the sine of cosine tangent x. So now when we want to do the derivative, if we just do this, f prime of x equals g prime of h of I of x. Let's see, wait. 1, 2, yeah, one more parenthesis. G prime of h of I of x times h prime of I of x times I prime of x. Notice we take the derivative of the outer shell, then times the derivative of the middle shell, then times the derivative of the inside. So that's exactly what we're going to do here, is we're going to say f prime of x is going to equal the derivative of sine x. What is that? It's cosine x. Well, what's our x? It's cosine of tangent x. So all I did was take the derivative of the outer shell. Now I have to take the derivative of cosine of tangent x. So I multiply that, and what's the derivative of cosine? It's negative sine of tangent x. And we need to make some room here. Okay. So, the derivative of sine is cosine, and just leave the cosine tangent going along for the ride. Then the derivative of the inside, the derivative of cosine is negative sine. Well, the tangent just goes along for the ride. Now we take the derivative of the inside, which is derivative of tangent, which is secant squared. So chain, chain, chain. All right, so if we want to put that whole thing together, it's fairly ugly. Now basically all you would do is stick the negative in front of the whole thing and bam, there it is. Let's see what the book did with it. Yeah, that's what they did. They just put the negative in front of the whole mess and you're there. So the chain rule has been used twice. And like I've said, I want you to expose your face to the proof, which is on page 224, but I'm more interested that you can actually use the chain rule and know why you have to use it and when you have to use it. So, that's it. Have fun with these.